Hi, this is Tomasz Kellner, Editor-in-Chief of GE Reports. Today we are in Cameri, Italy, where great things are happening in additive technologies for Avio Aero, the GE aviation business. We just drove 5 minutes from Cameri, an ancient Italian town, to arrive at what's Europe's most advanced additive manufacturing facility. Come with us for a visit at GE Aviation's Avio Aero business. Hi there.
Hey, hi Thomas.
How are you?
Fine. And you?
Nice to meet you.
Nice to meet you too. I'm Dario, manufacturing engineer of this Cameri plant.
Thanks so much for having us. We hear a lot about additive manufacturing, but what is it exactly? Can you describe it for us?
Yeah, for sure. Additive manufacturing is a completely breakthrough technology with respect to the past because we are adding material layer by layer in order to obtain a net shape product. In the past, we usually cut material, so subtracting material. So that's a huge advantage with respect to the past.
Now, why is it so beneficial for your company, for GE and for Avio Aero?
It's beneficial for different aspects because we are for sure saving material, so we are more green and we are saving cost. And also from the design point of view, we have huge advantages in terms of degrees of freedom. So our designers are very happy to this because they can use the material only when is needed, and it's the maximum aspiration for a design engineer.
Great. Well, can we see some additive manufacturing machines?
Yeah, for sure. Follow me. I can show you.
Let's go. Dario,
Yeah.
so here we are in the additive manufacturing factory. Now, what's happening in these black boxes?
You are right. This is one of the two technology that we have here. This is the electron beam melting. So inside of these black boxes, basically we have no more than an old television, but the electron beam, in this case, instead of drawing images on a screen, is drawing images on a bed of powder. And what we are obtaining is layer by layer this kind of product.
So what happens is the electron beam shoots down from the top to the powder of the material and basically welds it layer by layer as you grow, right?
Correct.
Now, how long does it take to produce a blade like this?
Yeah, it depends by the size, but we are talking about 2 or 3 days. It depends by the size of the blade, but you have to imagine that we are not building only one blade per shot, but we are building a cluster of 6, 8, 9 blades. It depends by the size.
So it's like a forest of blades inside that machine.
Yeah, it's like a forest.
Now, Dario, tell me, how does one become an additive manufacturing engineer? I mean, these technologies are so new. I mean, you're young, but you couldn't have possibly studied them in school.
No, I studied mechanical engineer at the Polytechnic of Turin, but tomorrow you will be in the Polytechnic, where now Avio has an additive lab. Very interesting.
Well, Dario, thank you so much for showing us around.
You're welcome. See you soon.
Thank you. Bye.
Bye-bye.
Hello.
Good morning, Thomas. Welcome. I'm Franco Tortarolo from Avio Aero, responsible of research programs.
Nice to meet you, Franco. So tell us about your research program.
We are at the campus of Politecnico, and Politecnico is one of the key actors for us in the frame of the network. We have a strong network for research and innovation.
Tell us about the network. So how does it work?
We started in the 90s, early in the 90s. To stay on the edge of the technological issues, we required collaboration and inclusion of universities and small medium enterprise. So we have a lot of collaborations with them.
So which universities are part of these networks, and what companies do you work with?
There are roughly 20 universities. Polytechnico is one of them. Then there are other minis in Italy, roughly 20 from the south to the north, and small medium enterprises that are supporting the research because they are flexible, cheap, and fast.
What are some of the technologies that are most exciting for you?
There are many technologies, but probably the most technology today is the additive manufacturing that we are developing since, let me say, 10 years with Polytechnico. And have you seen Cameri? So that's Cameri is the plant that has been basically from these collaborations, and now we are going to launch a joint lab fully dedicated to the research of additive manufacturing here at Polytechnico, which is that part of the building.
Tell us about the lab. What's going to be happening inside?
We are going to recruit young talents and develop new materials, new components to test new machines. It will be an area of 600 square meters roughly, with 4 or 5 machines of the last generation, and we'll try to expand the future of the components using this technology.
Great. Well, Franco, thank you so much for talking to us.
Thank you to you.
Very nice to meet you.
Bye-bye. Thank you very much. Bye.
We just arrived at the Polytechnic in Bari. This place, together with the Polytechnic in Turin, belongs to a network of university research labs helping Avio Aero and GE Aviation develop next-generation additive technologies. Engineers over here are specifically focusing on future repair techniques for jet engines like cold spray and laser repair. Hello.
Hello. Hi, Tomas. Nice to meet you. I'm Gregorio. Welcome to the Apulia Repair Development Center.
Thanks so much.
This is a new lab that we opened last November, and is a partnership between Avio Aero and the Polytechnic of Bari.
Let's go take a look.
Yeah, let's go. Follow me. So this is the laser deposition equipment, and you know, laser deposition, powder-fed laser deposition is well-established technologies that we have completed with more innovation. We have digital definition of the deposition through reverse engineering, and we have online control of the laser deposition parameters through control of the melting pool.
And what kind of components do you fix here?
First of all, we will fix turbine blades, also with some difficult materials like titanium aluminide, but we can also process aluminum or other kind of nickel alloys.
And how does the laser deposition technology work?
So it works in this way. You have a laser beam creating a very little and controlled melting pool on the base material. Then there is the powder injection with the material, the metal that you select, and the powder melt in the melting pool, so you can obtain addition of material on an existing layer, and you can build it layer by layer.
So basically, if there's a part of the blade missing, you can rebuild it back up with this technology and repair it.
You can rebuild it with almost every kind of geometry, and with very little amount of overstock.
And Gregorio, what other machines do you have in this lab?
We have the cold spray equipment that I can show you.
Okay, let's go. And Gregorio, what is this machine?
This is our cold spray equipment.
And what does it do?
The cold spray is a very innovative repair technologies, and it is able to rebuild part of one component by spraying metallic powder at high velocity.
Can you tell me how does it work and how high the velocity is that makes the particles fly?
The velocity is several times the speed of sound, and it is able to obtain ablation of the metal particle without fusion and without melting. So the innovation is mainly on this.
So basically the particle flies so fast, several times the speed of sound, that when it hits the blade or the component that you need to repair, it just sticks.
Yes, that's right. We don't have fusion, we don't have heat transfer, we don't affect in any way the geometry and the structural properties of the base material, and this is very important when you try to repair something already existing.
And this also belongs to the family of additive technologies, right?
Yes, there is potentially no limitation to the amount of material that you can rebuild, and you can also rebuild very complex 3D geometries.
And what kind of components would you repair with this machine?
Mainly we will repair aluminum and magnesium gearbox housing, and also aero engines turbine blades.
Well, Gregorio, thanks so much for showing us around your lab today. Welcome to Pomigliano, an industrial suburb just outside of Naples. Many large companies have their factories here, including Avio Aero, a GE aviation business. They make next generation engines here that include additive parts. Let's take a look. Hello.
Welcome.
Hi, nice to meet you.
My name is Giacomo Veneruso. I am a manufacturing engineer of Airfoil Center here in Pomigliano.
Giacomo, what is it that you're holding in your hand?
This is a 3D blade printed that we are now working in our Airfoil Center.
Now this blade looks very different than the one we saw in Cameri, where they actually were printed.
Yes, of course, because you saw a casting one that we machine inside our excellent center area.
Now why would you make a blade for jet engine on a 3D printer instead of, say, stamp it? What is the benefit?
The answer is very easy. Try.
Wow, it's very light.
Very light.
So what are the benefits? So if you have a light printed blade, then you have a lighter jet engine?
Of course.
What material is it made from?
This is titanium aluminide. It's a new material that we use to LPT stage 4, 5 and 6 on Gen X new engine.
So this is the LPT stands for the low pressure turbine,
Yes,
right?
of course.
And the GE9X, I see signs for the GE9X all over displays.
Yes, everywhere.
That is the world's largest jet engine.
You are right.
That the GE is right now assembling.
Yes,
and
it's
testing.
a big challenge for yes, big challenge for everyone that is working on.
Great. Well, Giacomo, thank you so much for having us.
Nice to meet you.
Nice
Welcome.
to meet you too. Hello. Nice to meet you.
Nice to meet you. My name is Carlo Silvestro. I'm engineering subsection manager here in Pomigliano plant, and we are working on GNPI programs.
Hey, Carlo, tell me about the Advanced Turboprop program.
Yes, sure, Tomasz. The ATP is the engine where we will utilize more additive manufactured parts than other engine in the aviation history. Here in Pomigliano, we are developing the ATP combustor.
Tell me about the ratio of additive components on this engine.
Yes, for this part we will replace almost 800 parts with 12 additive manufacturer parts. So we will have on the engine that 35% of the engine will be produced by additive manufacturing.
That is really interesting. And so exactly what in Pomigliano you are trying to figure out how to manufacture these new parts, because this is for the first time. No one has done this before.
This is the first time. We already received some prototype from ATC. We are developing this new combustor chamber. This is, let's say, an innovation for GE Aviation, because it's the first time we are developing and producing a reverse flow combustor chamber.
Very good. Well, Carlo, thank you so much for talking to us. Let's take a look at the manufacturing.
Okay.
Hi Tomasz, how are you?
Nice to meet you.
Nice to meet you. I am Eugenio Zerenga. I am NPI lead in Combustor Center in the Manufacturing Technology Department.
Eugenio, I have a question for you. We just heard about the new advanced turboprop, and that about a third of the engine is going to be produced on additive manufacturing machines. Give us an example. What do you do here?
Yes, it's correct. On ATP combustor, this is our first experience on additive material, and we try to set usually process that conventional and non-conventional process that we use on normal raw material, forging and casting, to apply at this part.
So it's a manufacturing process because it is so new that you actually have to test it out.
Yes, yes. We try to test this process and share also with other side, just to give our experience on this part.
So what are you testing right now?
Yes, the testing is conventional operation. We already done the turning operation, milling operation, and this moment it's possible to see the outer liner in laser machine, okay? While here it's possible to see the inner liner. Also this part wait to perform the laser drilling operation.
So I can see, so this entire part, this large part was 3D printed?
Yes, yes, this and also the outer. At the final, both part we assemble also in our house.
Great. Well, Eugenio, thank you so much for showing us around.
Okay, very thanks.
We have a long journey ahead of us, but you should feel very comfortable that Italy and Avio Aero are going to be in the center of the growth of our additive ecosystem as we go forward.